Currently, in the automotive market, it is possible to find electric compressors designed for retrofitting in vehicles with combustion engines. These solutions allow the air conditioning system to operate independently from the engine's mechanical power, improving efficiency and offering new installation possibilities. In this video, we explore 6 key aspects you should know before installing an electric compressor in your vehicle. 1. Automotive electric compressor voltages. A. The most common electric compressors sold for automotive retrofits, intended for vehicles with combustion engines, are compressors that operate at 12 volts or 24 volts. B. In contrast, electric compressors used in air conditioning systems for electric or hybrid vehicles operate at 400 to 800 volts, offering greater efficiency, higher performance, and lower current consumption. C. Most types of electric compressors are of the scroll type, due to their energy efficiency, compact size, and quiet operation. 2. Power consumption and cooling capacity. A 12-volt compressor typically draws between 45 and 100 amps, while 24-volt models draw between 32 and 60 amps. B. If the vehicle's electrical system is not properly prepared to handle the electric compressor, the high current draw of 12-volt models can cause voltage drops and system failures. C. The model or cooling capacity of the electric compressor should be selected based on the size of the vehicle. Typically, capacities range from 6,000 BTU per hour for very small vehicles to 20,000 BTU per hour for medium and larger vehicles. D. Installing a 12-volt compressor requires proper wiring, secure connections, and appropriate relays and fuses to ensure safety. 3. Electronic control of the electric compressor. A simple control method for an automotive electric compressor is a 3-speed switch, often used in basic retrofit setups. B. For more precise control, some compressors use pulse width modulation, PWM. C. The simplest and most affordable electric compressor retrofit kits use basic controls, such as speed switches and thermostats. 4. Vehicle electrical system modifications. A. Typically, a higher capacity alternator is required to meet the current demand without overloading the electrical system, especially in vehicles using larger electric compressors. B. If the original alternator is not sufficient, it will operate at its limit, causing excess heat and premature failure. C. A standard 12-volt battery with a capacity between 50 and 100 amp hours can quickly be drained by high-consumption compressors. D. To operate the AC with the engine turned off, the battery must be replaced with a much higher capacity unit, measured in amp hours. E. A 70 amp hour battery could theoretically power a 50 amp compressor for just over an hour, but deep discharge may damage the battery. F. At low engine RPM, the original vehicle alternator may produce less current, which can affect the compressor and other systems. G. If the compressor's current draw accounts for a large portion of the alternator's capacity, there may not be enough current left for the vehicle's other components. 5. Electrical evaluation and recommendations. A. To determine whether a higher capacity battery is needed, consider the compressor's power draw and how long you want it to run with the engine off. B. To evaluate if a more powerful alternator is required, add up the vehicle's total power demand, including the compressor, and compare it to the original alternator's output. If it's near the limit, upgrade the alternator. As a general guide, it is recommended: A. A battery rated between 70 and 100 amp hours. B. Use alternators rated above 100 amps for 12-volt compressors. C. Upgraded alternators rated 120, 145 amps or more provide a more reliable electrical system. Add a 20% safety margin to the total current demand. D. Proper high-capacity fuses and relays must also be installed. E. It is advisable to power the electric compressor via a dedicated circuit connected directly to the battery or alternator, with its own fuse and relay. 6. Installation challenges and safety. A. Installing an electric compressor requires automotive electrical knowledge, proper component selection, and correct installation. B. The safety and performance of this system depend greatly on a proper and professional electrical installation.